Audio Jungle.
Hello everyone, we are from Group 7 and today we will be presenting our signal assignment titled Convolution. And I will be covering the key concept of the convolution. So going on to the introduction of convolution, mathematically, convolution is defined as an integral operation between two functions x and y, which typically expressed as x times yt equals to the integration of x talks times yt talks d talk, where the talk represents the sliding variable. And for the continuous signals, the convolution integral is x times y dot yt equals to the integration of x dot times yt minus dot d dot with the limit of negative infinity to infinity. So for the convolution have three mathematical properties, which is commutative, associative, and distributive. At last, in linear system theory, convolution represents the system's output when given an input signal. So mathematically, modeling how linear time invariant system responds to arbitrary inputs by combining the system impulse response with the input signal.
For task 1, question 1, we need to develop MATLAB code to regenerate GT and HD signal based on the given signals in figures 1a and 1b. So first of all, we need to analyze the GT signal and HD signal. We can see that the GT signal is a triangular signal and the HD is a rectangular wave signals. This is a MATLAB code for GT signals. This is a MATLAB code for HD signals. By running the MATLAB code we generate, we can exactly recreate the signals as shown in the figures 1a and 1b. By observing the shape and the amplitude, we can see that the signals we generate are quite similar to the original signals. This will allow us to inspect the properties of the two input signals visually for the following question.
Okay, for task 1 2, we need to calculate the sum of the two signals, which is Zt is equal to Gt plus Ht. So the values of Zt will be obtained by adding values of Gt and Ht at every instant of time. First, we can obtain the expression of Gt and Ht from their graph by using this table method. Okay, for Gt, we will get this equation by using this table method, and also for Ht, we will obtain this equation by using this table method. After that, we can look at both tables to add the values at every instant of time. For this question, we can see that when t is less than negative 2 and t is in between negative 2 and negative 1, the output will become 0. So for t is in between of negative 1 and 0, the GT will have a t plus 1 equation and add with ht equals to 2. So the output will become t plus 1 plus 2 and obtained as a t plus 3. Same goes for the other t value. From 0 to 1, the GT will have t plus 1 and ht equals 0. Thus the ZT will be add, and get the result of t plus 1. So after that we can plot them up, and to verify, we use the table method to get the equation for ZT. Thus we develop the MATLAB code from the equation, and after running the code, we get the exact same signal as our plotted signal.
Task 1 Part 3 is talk about the convolution of HT and GT signal. Since the convolution integral is symmetry to GT and HT, the result of convolution of GT and HT is same as the result of convolution of HT and GT. In this question, GT acts as the impulse response. So first of all, we will plot the signal of GT and HT. Plotting helps us understand the behavior of the signal over time and find the region where they overlap. Afterward, we express GT and HT in terms of tau, so they become G tau and H tau. This change allows us to shift G tau and relative to H tau. The next step is to replace tau in G tau with T minus tau, which will give us GT minus tau, which is a full and shift version of G tau. Then the product Y bracket T tau equal to H tau G gt minus tau is integrated as a product of tau. The next step is to replace tau in g tau with t minus tau, which will give us gt minus tau, which is a flow and shift version of g tau. Then the product y bracket t tau equal to h tau times g t minus tau is the integral as a product of tau. Right now we go through to this convolution of signal in certain time. When t is lesser than -2, there's no overlapping between two signals, so the yt is 0. And then for t is between -2 and -1, you can see it's small overlap in here. So we can see that yt equation is t squared plus 4t plus 4. When t is between -1 and 0, you can see the signal of the triangle is fully overlap the higher rectangular. So yt is equal to 2t plus 3. And then for t is between 0 and 1, you can see the triangle is overlap between with two columns. Okay. And then the yt equation is negative t squared divided 2 minus 2t plus 3. So when t is between 1 and 2, and then the triangle is fully overlap in the small column, the yt equation is equal to t minus 1 divided by 2. And then for t between 2 and 3, you can see the triangle want to go out the small column but still overlap. And then the yt equation is minus t squared divided by 2 plus t plus 3 divided by 2. And then we go to the last one, which is t greater than 3. You can see the triangle is fully go through two columns. So we can see that yt there's no overlapping between t greater than 3. So the yt equation is 0. Therefore, for the t and the output signal, yt is here. We find out of yt for each time interval and combine them. After that, the output of yt can be plotted. Then write the simulate code to verify our solution. This is our solution in MATLAB.
Okay, so now we are going to do the task 2 part of this assignment. In this task, we are given an input signal ft equals ramp t multiplied by ut minus 1. This input signal is fed into an LTI system ht. Our objective here is to analyze the output yt. So first of all, we need to graph and plot ft. ft consists of two parts, the ramp and the unit step function. We graph the ramp on its own and then the unit step function, as we can see here, and then multiply them to get the input signal. And then we will have to find the graph for ht. As shown here, we will use the tabular method to find the graph of ht and plot. And now we have to evaluate the convolution results. Here ft acts as an impulse function. So we plot the ft minus tau, where ft minus tau is a folded and shifted version of the f tau. And f tau is equal to negative tau. Afterwards, we will have the ht be represented as h tau. And then, after plotting, we will have the product of both functions integrated as a function of tau. The integration can be viewed as the area under the curve represented by the integral. Here, for each time interval, we will find the output of yt. For t less than 0, the output of the yt is 0. From 0 to 1, the output of yt is 3 over 4 t squared. And from 1 to 1.5, the output of yt is 3 over 4. From 1.5 to 2, the output of yt is negative 3t squared over 4 plus 9t over 4 minus 15 over 16. And from 2 to 2.5, the output of yt is 5t squared over 4 plus 17t over 4 minus 47 over 6. From the intervals 2.5 to 3, the output is negative t squared over 2 plus 9 over 8. From the intervals from 3 to 3.5, the output is t squared over 2 minus 5t over 2 plus 21 over 8. And anything from 3.5 to infinity, the output is 0. After getting the output for all intervals, then we can plot the graph out. And finally, using the formula given, we can write the MATLAB code and get the output yt. Here we can see that the output yt given by MATLAB is similar to the one we got. So we can verify our answers that way.